Okay guys, so we're talking about limits today. Okay, so if I make a statement here, limit x tends to 7 if x is equal to 5. So what exactly do I mean by this statement? See, the statement has two components. One is the limit part and the second is the fx part. Fx is nothing but y is a function of x, basically the function of x. Okay, so we'll study about these two components in the subsequent slides, but if I have to tell you in a very layman's language, I can just say that as x approaches 7, the value of y approaches 5. Okay. Okay, let's talk about the function fx. Now there are two ways to explain this function f of x or a function of x. Basically, this means that y depends upon x. Okay. One is, of course, I can explain graphically, and the second is we can also understand this concept by a algebraic method. Okay, now let's say, talking algebraically, we can say that y is a function of x is x squared minus 4. It's basically an equation which is of degree 2, right? So I can put in some values of x here in this equation, and I get the subsequent values of y. Okay, now let's say I put in a value of x is equal to 3. So what happens is this value of x is being processed in this equation, say 3 square minus 4, and I get the value of y, which is output as 5. Okay, I put x is equal to 4. Now the value 4 is processed in this equation, so it becomes 4 square minus 4. The answer is 12, and I get the answer or the output y is equal to 12. If I put x is equal to 5, this becomes 5 square minus 4, which is nothing but 25 minus 4, which is 21. Okay, so I get the output here as 21. Now, note this very important point when you define a function, and that is that the value of y has to be unique in relation to x. If I put a value of x is equal to 5, and I get the value of y as 21, and if I put the value of x again as x is equal to 5, I cannot get the value of y which is some other number other than 21. So let's say I can't have y is equal to 21 and y is equal to 25. Okay, so that's not possible, that's not permitted, because I would not know what value to choose from. Okay, so there's going to be a lot of confusion for that. So the value of y is basically unique to x. So every x will have only one value of y. Okay, but the converse is typically not true, which means that I can have a multiple x which would give me the same value of y. Say for example, if I have a value of x as minus 5, okay, and I put this minus 5 in this equation, I still get minus 5 the whole square minus 4 as 21. So y is still 21. So for two values of x, I get the same value of y. Okay. So basically what it says is that for every x I input, I get a value of y. Okay, so it's a relationship between x and y. Now, if I have to explain this graphically, all I do is simply take these points and I draw a curve with the help of these points. Okay, so for example, I have x is 3, y is 5, when x is 4, y is 12, and when x is 5, y is 21. So I take these 3 points and I draw a curve with that. Okay, so I'm taking these 3 points here and I'll draw a smooth curve. Okay, now what is this? This becomes my expression y is equal to fx. Okay, so this curve is nothing but y is equal to fx. Again, here it means that I take any value of x, go up the curve, and I get the corresponding value of y. So again, a relationship between x and y. but this time it's explained graphically. Okay. Now let's go to the next component, which is limit x tends to 7 fx. Okay. Now notice that we are saying x is tending or leaning towards 7. Okay, this is not the same as x is equal to 7. So there's a difference between x tending to 7 and x is equal to 7. In fact, I'm not really interested in knowing what happens when x is equal to 7. But I am more interested in knowing what happens when x is around 7 or x is close to 7. So when I say x is close to 7, x can be close to 7 in two ways. One is x can be less than 7, which is, let's say, 6.999999, very close to 7. Or it can be slightly higher than 7, which is, say, 7.00001. So either case, x is close to 7 or x is tending towards 7. So simply put, what it means is I take these values of 6.99999 or 7.00001, okay, whenever I say x tends to 7. Okay, now with these two concepts, let's talk about limit. Okay, so let's say I'm drawing a curve here, y is equal to fx. Okay, so this is a curve y is equal to fx. Now I take a point on the curve, any point arbitrarily on the curve. Let's say at x is equal to 7, and corresponding value of y at that point is 5. Okay. Now, as I mentioned before, I am more interested in finding out the behavior of this x and y relationship closer to the point 7, not exactly at 7. So I approach this point from below the curve, which means I take a value which is slightly less than 7 or 6.9999, and I go up the curve, y is equal to fx. I get a corresponding value of y which is very approximately close to 5. Okay. Now I approach this curve from the top, which means I approach this point from the top of this curve, or a value of x which is slightly more than 7, so which is, let's say, 7.0001. So again, when I approach this point from 7.0001, I go to the curve fx, I get the value of y as 5, which means either way, x less than 7 or slightly more than 7, which I say limit x tends to 7, I get the value of fx is equal to 5. Okay, so when I say x tends, I'm basically saying it's nearly equal to 7, but not exactly equal to 7. So when I say when x tends to 7, y actually tends to 5. But for all practical purposes, because I would not be dealing with decimals and those numbers as output, so I say for all practical reasons y equals 5. Okay, so I say limit x tends to 7, f of x equals 5. So guys, in short, what we have learned today is that I plug in some values of x, okay, very close to let's say 7, which we were discussing earlier, 6.99 or 7.001. Okay, and I get the corresponding value of y as 5. So it's a relationship between x and y. When x tends to 7, y is equal to 5. Okay,